All right, doing these a little out of order today. Now we're going from, how about this? Let's start with number 15, okay? Now we're going to rewrite this in exponential form. Now currently it's in radical form because there's a radical there, okay? So this number, the exponent, will always go in the numerator. This number will be the denominator. So what we can see here is that the third root of 7 to the 5th power can be written as 7 to the 3/5 power. Okay? Just like here, there's a magical little 2 in there. All right? So this would be 7 to the, let's see here, that goes up top, 3. This number goes on bottom, 2. So 7 to the 3/2 power. All right? Now, the square root of 6 is going to be the same thing. Now, there's a 2 in there, and there's a 1 right there. So this is actually 6 to the 1/2 power. It's really good to note, anytime you just have a square root, that's to the 1/2 power. And then for number 18, this will be 6 to the 5/3, just like number 15, okay? Now, if we're going the other way with this, other direction, start with a root. That 4 goes right in there. Then we have a choice. We either put 2 to the 3rd there, or we can also rewrite that as the 4th root of 2 to the 3rd power. Either one of those represents essentially the same thing, okay? Now, we're just writing it in radical form. Does it have a radical? It does, so we're done. Now, this one, when there's a 2 there, just like we talked about down here, that means there's a square root. So it'd be the square root of 5 to the 3rd power, or root 5 to the 3rd power in there. Be careful how you write them, okay? Now, since we could put a 2 in there if we really needed to, but we don't need to because square root's basically its own entity anyway. It's its own thing. Now, 4 to the 1/3 power here, this is going to be the 3rd root of 4. That's it. And then here, we have 10, and we have a 3 there, so I'm going to put a 3 in the 3rd root, but then we either put the 4th there, 10 to the 4th power, or we do the 3rd root of 10 in parentheses to the 4th power. All right, now I'm only going to do a few of these. So this will be, let's see here. This is the 5th root of 3. That's really all you need to do there. This will be the 4th root of 5 to the 3rd, or the 4th root of 5 to the 3rd power. Okay, and down here, number 24. Let's do 24. This will be 10 to the 4/5 power. That 4 goes up top. This 5 is the denominator, and then this would be 6 to the 2/3. All right? Now with these, we have multiple terms in some of these, so we got to worry about them. So that means if this, on 28, on 28, since 3b is in there, then I would have the 4th root of 3b, and then take that to the 3rd power. Now, I've shown multiple different ways of writing these. There's another way. I wouldn't suggest doing this, but if you don't want to put the parentheses, then you'd have 3b, well, I guess you still have to have parentheses then, to the 3rd in there. Okay? Now it's in radical form. So, number 30 would be the 6th root of 2p to the 3rd. Now, since there's a 1 power or a 1st power there, we don't have to worry about anything else, okay? We just take what's inside these parentheses and put it right there. So we're good. All right, now if we're going back to exponential form from radical form, let's take 32, for instance. This is going to be p to the 2/3 power. Probably shouldn't have done that one. We need something with 2 variables here. 31. This would be 7x to the 1/2 power, because square root is going to be 1/2. Okay? And then number 34, let me skip down here and do this one. I have 5b. Now, since it's 2 terms, I'm putting them in parentheses. And that's going to be to the 2/3 power. Just like the p, 2/3 power, the 5b. And I'm going to make that look better. This looks kind of gross. So, parentheses, 5b to the 2/3 power. All right, now back to the top of this one. I mean, wowzers here. We have to do a lot of stuff and remember a lot of rules, okay? So I'm going to try and go slowly so we remember the rules. Now, this first step right here, dealing with this and this, all right? If it's a power of a power, we multiply. And n to the 3 halves, so if I take 3 halves and multiply by -2, that's like -2 over 1. So then the first part, this would be n to the, well, it would be -6 over 2, which would be -3, n to the -3rd power. And this is multiplied by, and I'm going to change colors, n squared. So if power of power is multiplying, now here, since I just have two terms being multiplied, I take the exponents and I add them together. This is the same thing as n to the -1st power, which is also can also be written as 1 over n. Now, these things are okay, but since it says only contain positive exponents, that's your answer right there. That's what you need to have. Now let me skip down here and do number 4. Since this is the power of a power, this is x negative 2, or we take 2 times -1, which is -2. Now, similarly, with the power of negative exponents here, this is the same thing as 1 over, and when you put it on the bottom, it changes to positive. So that's all you have to do with that one. So 1 and 4 are donezo. Let me switch colors here. How about number 6? Number 6, this is the power of a power, so we have to multiply those. So this is n to the, it'd be 3 over 2 times 3 over 4. Now when you're multiplying fractions, you just multiply. 3 times 3 is 9, 2 times 4 is 8. So this is actually the same thing as n to the 9/8 power. All right. And no worries about the denominator there. Now over here, number 5, this is going to be kind of an issue. So let me go ahead and clear this and scroll down for a second. All right, number 5. Kind of a messy one here. And here's why. If you read the directions, we can't have any fractional exponents in the denominator. So here's what we have here. This is the same thing as, well, we have to multiply -2 times 1/4, which is the same thing as -2 over 4, which would be -1/2. So you technically have k to the -1/2 power. That's not the problem. When you rewrite this, it's actually 1 over k to the 1/2 power. Now that's a fractional exponent in the denominator. This is the same thing as 1 over square root of k. Can we have that? No. So we have to rationalize it. We have to multiply by square root of k over the square root of k. And that's why our final answer, and I'll write that in bleh, is going to be the root k over, now root k times root k would be the square root of k squared. That's why we did it. K. All right. So that's what we do there. Now, I don't think we're going to run into the issue again until maybe down here. But I'll try and do that problem as well. Maybe, yeah, a little bit of here too. So, let me do number 8 real quick, just to give you a heads up. Number 8, 2 and 4 both divisible by 2. So we end up with first a 2 down here. That goes away. Now, since we're dividing these two, we have to take the fractions, or the exponents, and subtract them. So what is 2 minus 5/3? Well, we can't do that. We have to get a common denominator. So I need to multiply this first fraction by 3 over 3, and I get 6/3 minus 5/3. What is 6 minus 5? That's 1. And 3 it stays. So what we really have here is n to the 1/3 power over 2. Now, there's no fractional exponent in the denominator, so then we're done. All right, and that's all well and good. Everything's fine there. Now, number 9, if we're subtracting those, once again, the 2 stays on the bottom because there's nothing else to simplify it with. But what we really have here is n to the 1/2 and -2, so we have to subtract those. What is 1/2 minus -2? Well, it'd be -2 over 1, so I need to multiply this by 2 over 2. I get 1/2 plus, since it's a negative times a negative, 4 over 2. So this would be 5/2. N to the 5/2. Since it's positive, it stays up top. No fractional exponent on the bottom. We're good. Now, number 10, this is where everything changes. Got to worry about this one. The 3 and the 4 are going to stay. 3 and 4. Now, you have k, and we have to take these two and subtract them. So what's -2 minus 1/2? So I need to multiply this by 2 over 2. I get -4 over 2 minus 1/2. So what this is going to be is -5 over 2. So since the fractional exponent is negative, we're going to move it to the bottom, and it becomes positive 5 over 2. Now, you can't have a fractional exponent in the denominator. Now, 5 halves, if we add 1 half to it, becomes 6 over 2, which is 3. So that's what we're going to do. We're going to try and rationalize this because we can't have a fraction down there. We're going to multiply by k to the 1 half for k to the 1 half, and we're going to see what happens, especially as we change the color here. The 3 is going to stay, the 4 is going to stay. The k to the 1 half is going to go up top. Now, on bottom, this is where the magic's happening. I already know that 5 halves plus 1 half is 6 halves. So then on bottom, I just end up with k to the third. Now, is this a fraction? No. So we're good. All right. You're going to finish the rest of the problems on this assignment. Thank you very much.